Hi everyone. So thank you Adil for the introduction. Hi, my name is Rudramadhaba Mishra. You can call me Rudra. So I would be giving a talk on Kubernetes and Istio. So a quick intro, a quick intro of myself. So I am a cloud engineer at Amazon AWS. So I hope you have used the platform AWS and heard about it. So we'll quickly go to the next slides. Uh, so it's a quick disclaimer that I am not speaking on behalf of AWS, and this entire session will be on open source and my personal views. So here's a quick agenda. So the first one will be we will be doing a quick go through of Kubernetes and understand what are the gateway APIs. And the next we will move towards service mesh and what is Istio and what are the features we are going to see in Istio. So we'll also look into the installation and configuration of Istio. How would you use it in day-to-day life? And secondly, we'll go towards how do we set up for a multi-cluster in a single mesh. We'll know what is mesh, okay. And the last part we will go for the mTLS, and we'll show you how mTLS works and what are the features, why are we using those, okay. So quick question, how many of you exactly use Kubernetes in their professional life? Okay, good show of hands. Okay, so yeah, before going towards Kubernetes, we'll just have a quick intro on what is containers, what is orchestration. So we every day ship lot of code, right? So when we once we are developed the code, we would like to deploy it into Kubernetes. Then we have to containerize it, right? So why do we exactly need containerization? So basically, before the microservices architecture, we had a monolithic architecture, right? So where people had this problem that if one code or one application fails, the entire system face some breakdowns, right? So then we move forward to microservices architecture, where we use this container orchestration, okay? So what are exactly containers? So I hope everyone has used Docker. Can we have a quick show of hands? If okay, great. So a huge number of crowd. So Docker file. Once we have written the Docker file, if you have used, as I see a lot of people are already working professionals. So when we have used this Docker file and we have containerizing the application in form of a smallest mode, that is the image, then we are done with this containerization, and Docker is the best way to mostly do a containerization, right? So what is exactly orchestration? It's basically we are automating the deployment, and where we are managing a lot of containers together so that they can communicate with each other, right, and with the external world. So the best way of container orchestration we know is Kubernetes, right? So it is helping us to manage a lot of containers simultaneously, right? So ensuring the high availability and with multiple hosts. You know, I mean, if you have done something wrong with the Docker file and we realize the container was running, but there were some port issues or something, I hope you have faced a lot of issues like this. So let's get into Kubernetes. So yeah, as I said, Kubernetes is the mode of orchestrating the containers, and what we knew how what is the orchestration process, and now basically why Kubernetes is the best way to orchestrate the microservices and the containers. So basically, it has a master slave model, which is basically the controller and the worker nodes. So what exactly happens in the control plane, where we have a entire control management system, under which we have a lot of worker nodes who are working for your applications and ensuring their up and high availability. We're ensuring the applications are running inside all those nodes. Okay. So here's a quick architecture of what is inside Kubernetes. So this is the entire cluster, for example, and we have this control plane and the worker nodes. So like in the control plane, this is a cloud control manager. It can be anything, right? It can be any cloud provider, AWS for example, or any other cloud provider. Okay. So inside that we have, in this control plane, we have a HCD. So what it does is like it's basically a key value data store management, and we also have a Q API server, which is basically the heart. Okay, and it manages the entire platform of the cluster. And we have scheduler inside control plane. What it does is basically it schedules for which application the pods will be aligned to. Okay, for example, there is a one pod, and which application it should be aligned to. I will get into what is pod and how we exactly connect with this. So this is the control plane, and we are moving towards the worker nodes. Okay, so in the worker nodes, we see there is a kube proxy and a kubelet. So what is kube proxy? Kube proxy is basically when we are like putting any network policies, okay, and we are ensuring that there is some networking configuration happening according to our cluster management process. So we have doing all those things is managed inside the kube proxy. And let's get into the pods. As I told, like I will be telling what is a pod. So basically, we knew about containers, what Docker is, and how we containerize it. But basically, a pod is like in pods, we have nothing, just containers, right? Okay. So a container is like wrapped inside the pod, and there can be multiple pods running inside a worker node. So this pods basically ensures that your application is inside those containers, inside the wrap of the pod, right? So slowly we will move towards the next slide. How we deploy in Kubernetes, right? I think most of them, like most of you people have deployed in Kubernetes. So anyone who hasn't deployed, that's a quick guide to how to deploy in K8s, and we'll slowly move towards the next step. So if you don't have a cloud platform, or you are not inside a privileged cloud platform, you can start with Minikube. That's basically it's open source, and you can just download it in internet. And to create a cluster, basically we use Minikube start, and the commands are the same, the kubectl create deployment, and we give this image name, because that is the Docker file that you have created with those image. So that is the kubectl create deployment. What it does is exactly it creates a deployment with those cluster configuration that I showed you just now with the worker nodes, and you can see if the deployment is done or not inside kubectl get deployments. Okay, so sometimes we face a lot of 503, 504, 503 mostly error. You can see if it exactly exposed to the external environment or not, right? So to expose to the external environment, we create a service for the deployment. So how to create a service? Basically, we expose the deployment with the deployment name and the port that you have given in the Docker file. Okay. So sometimes what happens is when we are configuring the port here with different port number, rather than that we have given the Docker file, it will be showing some 503 errors. So like these troubleshooting, I hope most of you have gone through. So this is why it is required to create a service so that we expose it to the external environment to use. So you will see a smalling output, like you can see, for example, the application name is hello node, and you can see there is one pod running, and we have just started the pod. For example, the age is 1 minute, and you can see inside a pod, inside the node, there are few pods, and inside the pod you can see your containerized application. That is the Docker image that you have containerized, and that's inside the pod wrapped, right? So we'll go to the next slide. I love Kubernetes, but yeah, let's do this. Okay. So what are the network policies that we exactly define inside the Kubernetes? So the network policies resources define, ingress and egress. So what is ingress? Basically the incoming traffic, right? So incoming traffic inside the Kubernetes or the pods is basically the ingress, and egress is what we exactly send outside of the Kubernetes pods to the external environment, right? For example, we want to access the pods outside of the Kubernetes cluster. So that is how we set the egress rules. So there are also a pod selector and a namespace selector. For example, which pod or which namespace we want to define for the network policy exactly to send the traffic. So we have also a few CNI, that is networking interfaces, the external ones, that is open source. You can use a few tools, and some of the enterprise solutions also, like Calico, Cilium, Web, and these things we are using for cloud networking, and for example, we are using for uh, putting out a middleware or a interface to connect between your Kubernetes and the external calls, right? So here's a quick example of how a network policy looks like. So we have this test network policy where we have defined the policy type for ingress and egress. You can see the IP blocks, okay? So these are, I hope everyone knows about CIDR. So like these are the ranges for the CIDR basically, and we have given this specific IPs, and you can see that we have blocked an IP, right? You can see there is an exception that this traffic won't be allowed, right? The incoming traffic from this IP won't be allowed. So we can be setting these rules inside a network policy inside the Kubernetes cluster. So you can see like we have also defined the which protocol we want to follow. We are using TCP right now. So for the port, and again for the egress, that is the external traffic. I mean, we are sending the traffic outside of the Kubernetes cluster. So that will be this CIDR range that we have defined. So this is how a network policy inside a Kubernetes looks like. So anyone having worked on gateways? Have you heard about gateways? Can we have a quick show of hands? Gateways, okay, okay. So so what is basically a gateway, right? I mean, let's say like you have a cluster and we have someone outside of the cluster. This is an external user, just like us opening let's say any page inside a cloud or anything that we are opening day-to-day lives, right? For example, Swiggy, Zomato, right? So we are using, and how the external user connects into the pods or inside of the Kubernetes cluster into your application that is inside the pod or basically inside the container. So this is what gateway does, right? So it connects and gives you a interface to connect your application to the external world, right? So what is a gateway API? So Kubernetes have a gateway API of its own. We will slowly move towards what is Istio and all, but this is something related to Kubernetes. We have Kubernetes, I mean a specific API for Kubernetes, that is the gateway APIs. So Kubernetes gateway API basically does nothing, but we have, for example, we want to do a HTTP request, right? There is a routing mechanism for HTTP. And for example, we will slowly get to know what is gateway, what is virtual service inside Istio. I'm just giving a quick interface. So how a gateway API of Kubernetes looks like. So a host name is basically the site that you have deployed, and that is the DNS basically of your application. And these are basically few rules, right? And we are sometimes saying it as matchers or matches, you can say. So there are different paths for it. For example, there is an application in Swiggy or Instamart that you are using day to day. So for example, we are logging in and getting into the cart, for example. So we are defining these paths slash login or slash cart, for example, inside the matchers. So basically, when an application, a external user wants to access that slash endpoint, I mean the slash cart or slash login or slash sign in, so it will be going to these matchers and find out to go to which gateway and which basically virtual service and which exactly the host name and exactly which Kubernetes pod you would like to go into, right? So this is how a gateway API inside the Kubernetes works like. So have anyone heard about service mesh? Okay. Like we have a lot of people using service mesh. So we heard about monolithic microservices architecture, but we also want like to know what is a service mesh, right? So service mesh is nothing but that's a basically a layer above your microservices architecture, which ensures that we have your entire application secured. Okay, so there are many use cases, but for mostly for security and giving a infrastructure layer, how we can communicate with the entire microservices between let's say we are communicating between two microservices, or we are communicating one microservices to the other. Example, we are also communicating external world with this one Kubernetes cluster or the pods basically. So we want this service mesh, and I will explain why. So basically, it provides some beautiful pictures. Like these features as basically the traffic management. Basically, we have heard about retries, right? So for example, we are trying to access our application, and we are getting a couple of errors, right? And we want this to have a retry mechanism so that there is no certain timeout, or how much do we want this application to get tried or retried before giving a timeout or error, right? We can set it inside service mesh like kind of architecture, where we are using, we are going to see how Istio is a service mesh and will help in traffic management. We also have security, this mutual TLS. Have you heard about mTLS? Anyone? Okay. So basically mTLS is nothing but is a mutual transport layer security. It's a protocol, and how we will be securing this using mTLS we will see. And we also have authorization and resilience. Why this is why we are using a service mesh architecture above this microservices layer, right? So we'll quickly go to the main topic, that is the Istio. So Istio is a open source service mesh, and it is a CNCF graduated project, if you have heard about. And it's basically providing you the infrastructure or the service mesh that is required for your communicating inside how I explained the service mesh. So it is the best example of a service mesh, open source service mesh architecture tool, that is Istio. What it provides is, we know, like we saw, whatever service mesh is getting the use cases we have inside that in Istio, right? So Istio has a great sidecar policy that we'll soon see, that is called Envoy. And if you have heard about Envoy, is basically it carries all the data plane inside the Istio, and it offloads the entire load from the containers that will be helping the Istio to run. So it will be entirely giving the network everything that is in the data networking. It will have inside the sidecar that will slowly see what is a sidecar. Okay. So if you have in the 90s, we had this thing, right? So we had this beautiful Royal Enfield with a side, car kind of thing, and where we can, have a partner sitting with us right now. So this is how Envoy works, right? So Envoy is nothing but a sidecar or a proxy, right? This is a proxy that is a pattern which helps to access the incoming and outgoing traffic. Basically, it offloads the entire load from the Istio containers towards the Envoy, so that it runs smoothly without any external load that is coming to the Istio traffic. Okay. So it enforces the security policies, the mTLS and RBACs. It also collects logs, which is very important. It also collects logs, metrics, traces. So if we are seeing any errors inside Istio, we can go and check the logs in Envoy or the Istio OD. We will slowly see what is that. So basically, how Envoy or this sidecar works. So we know, like this Istio, right? So there is a client who is accessing the Istio from externally, basically the applications from an downstream or basically the external world. So it will be coming to this service mesh, and where we have this service A, that is our microservice, which is attached to this Envoy proxy, and where we are getting to our destination. Oh, what is our destination? Basically the microservices, right? Which where we have deployed the applications. So this connects us to this, our final destination that we just got to know about Kubernetes. So basically, when a pod starts, we saw how to deploy a Kubernetes, right? So how we deployed and Kubernetes and the pod gets started, we just saw that. So basically at that point of time, if we have Istio, we'll know how to install Istio soon. But once it is done, so basically what will happen, it will inject a Envoy sidecar and to the container to offload the entire load to the Envoy proxy. And it will apply the routing rules. I told you, right, we have virtual services apart from gateways. So these are basically the services, or basically the rules, a set of rules that we define that which matcher or which Kubernetes application our traffic should route to. So we have also the security policies that can be inside the Envoy, that is peer authentication, mTLS, and of course the load balancing, destination rules. For example, we want to have few authentication policies or authorization policies also. We can be able to define inside Istio, which goes to Envoy ultimately. And of course, we can be easily using this for our HTTP traffics and gRPCs also, right? Yeah, every Envoy gets a sidecar proxy. I mean, every Istio container will be getting a sidecar proxy, right? So a quick installation of Istio, and you can use this command istioctl to install. First, ensure if istioctl is installed, that you can set up, and you can use this istioctl to deploy a Kubernetes, a Istio application, where we can be deploying the Istioid and Istio core applications. So this will help us to inject this application for our microservices layer, right? So how we define basically a kubectl namespace, that is Istiod, and Istio injection is enabled, then basically Envoy is attached. Okay. If it is not done, this Istio injection is not done, we don't have an Envoy proxy, right? So of course, we can Google these things, and I have these applications, these links to go through. You can check for the Istio documentation to install Istio basically, right? So what is a gateway, and how we define these virtual services? We'll slowly get into it. And this is the ingress gateway. So for the incoming traffic, we are defining the port and the protocol. And this host is basically our DNS, where we are trying to deploy the application, right? For example, it is xyz.com, and we have this HTTP protocol with a port number 80, and we have this gateway defined as XYZ gateway, right? So I also showed you in the agenda that we are looking into multiple clusters. For example, we have two Kubernetes cluster, and we want to expose it to the external world. And how we'll do that, right? For example, there are basically two Kubernetes services, microservices. So we want to have a sign-in for a different Kubernetes service, and you want to have a login for a different Kubernetes service. Okay. So we can do that in Istio. So we are defining a XYZ virtual service, where we have this host as usual, our xyz.com, and the gateway that we just defined that will access the entire virtual service, right, through the gateway. And we have this destination, that is our first Kubernetes service. And for the Kubernetes service A, we have sign-in, right? Our prefix is sign-in. That means, for example, xyz.com/ we have sign-in. Then it will route to this Kubernetes application to access the containers that we have just deployed in the 9090 port. And we also have a login similarly for a different Kubernetes service, that is service B, right? So that we have a microservices layer as well as two different microservices for two different routes. I hope you are getting it, right? So mostly we are almost at the end of the slides. We also sometimes deploy VMs, right? Instead of Kubernetes, we are also deploying in VMs. So if you have any VM or you have any external, for example, Cloud Run or something like that, we don't have in Kubernetes right now. So those old or legacy application can be deployed using service entry. So in the service entry, we will be giving the host as that Cloud Run URL, or for example, the IP we want to, or this VM IP we want to, and we can expose the, for example, we are doing it for HTTPS, we have 443 port, and of course, for example, we want to do the resolution in DNS, and we have to do that. So of course, कितना भी soul सीख लो, you know, कुछ तो छूट ही जाएगा. We are just at the more use cases of Istio. So we have this rate limiting, right? So for rate limiting, if we are accessing the application and we see 1,000 or loads of traffic coming, and we won't want that traffic that is something that is unusual or that won't happen inside our application regularly, we can put a rate limiting inside the Istio to protect the how much amount of traffic you really want the application to access. And they will have also retry policy, which I have explained. And there is also circuit breaking, which we can implement inside our Istio. So this is the last part of, basically, there are multiple, use cases, and there are multiple policies or rules that we can set in Istio. But something which I will get into, this is like authorization policy and mTLS. You can see in this documentation as well. So basically what happens is mTLS, that is a transport layer security. So in mTLS, that is a mutual transport layer security. So what would happen is when we have a server and we are accessing the client, the client is accessing the server. In TLS, it's not mutual, right? It's only like authenticating the server side. But in mTLS, what will happen? It will happen both sides, right? The server will also authenticate the client, and the client will also authenticate the server. It will be mutual. So this is what mTLS is. And for example, we can set a strict policy inside Istio. What will happen once we are doing a strict policy, that means mTLS will be allowed. If we are doing for permissive, that means we also want to allow plain text in the networking side, and we also want the mTLS. That is a permissive policy, and the another one is strict policy. Strict policy means it will only allow mTLS. You can see in this documentation as well, right? Yeah, go bold and let's use Istio. Okay. Yeah, thank you for the slides. The great audience with a quick show of hands who understood this. Can we have a quick show? Yeah, thank you. So basically, this was my first talk, and thanks to Atul that gave me the opportunity to speak at this community. And do we have any questions?